Today we're starting a new unit, Unit 7, which is all about polynomials. So there's a lot of vocabulary that we're going to have to go over, and we'll break it down so you understand what it all means. So poly in itself means many. You think about polygamy, that's the word that means many, like many wives, many husbands, whatever it may mean. And then nomial means term. So a polynomial means many terms. So we think about terms as being a monomial, a single term, or a sum or combination of those. So we can have many terms put together, either adding or subtracting. We use the word sum, but it's also think about combining. It could be negative and positive numbers. So think of polynomial as a large umbrella. And so we can think about all of these things being called polynomials, but then we can more specifically give them a more detailed name. So the first thing is understanding what a monomial is. So mono, the very root of monomial, means one. So a monomial is a polynomial, so it can fit under that umbrella, that is one term. A term can be either a constant, which is just a number, like the number 5. It could be a variable, which is a letter, like x, or it could be a constant with a variable, like 5x. Now, things that we have to remember. Variables cannot have a negative or fractional exponent. So x to the negative 2, even though it's one term, because it's a negative exponent, is not considered a monomial, so therefore it's not a polynomial. It can't have a fractional exponent, like x to the 1/3, again for the same reason. And you can't have a variable in the denominator. Now there's a little bit of hitch to this one that we'll talk about in a minute. So this one is c to the 3rd, which is fine, divided by d, but it doesn't simplify down. So that d in the bottom cannot be there because it's a variable. It's in the denominator. We can't have anything that's in a radical sign. So we can't have like the square root of 2 there. Or we can't have x to the square root of 2. It's going to be something that gives us a positive number in our exponent. Okay? So some examples that are monomials, we have r to the 5th divided by 25. Well, there's not a variable in the bottom, so that is considered one term. You don't see these very often, but they are there. Then we have a number, 8, a constant, a variable raised to a positive, and they're all been multiplied together, so this is considered one whole term. So that's a monomial, or can be called, in general, a polynomial. This, a number, a variable, a variable, a variable, positive exponents. We know there's an exponent of 1 on each of these. Then we know this is whole together, a monomial. It's one term. They've been multiplied together. 4, just a number, one term. It's a monomial. And then we also call that a constant. This one has a little star because I told you before we can't have a variable in the bottom, so you would think immediately it's not. However, this reduces. 12 divided by 3 is actually 4. And a7 divided by a to the 4th, they have the same base, a to the 3rd. So this simplifies down, and it is a monomial. So we always have to think about simplifying as well. Now the next word we're going to talk about is binomial. So the beginning of this word, bi, means two. So this is a combination, either sum or difference, of two terms, or two monomials together make a binomial. So we have a term here, and they're added together. That's a binomial. Here we have a term, and it's a binomial. A term and a term, they just happen to be subtracted from each other. They're not like terms, so we can't simplify them. If we have something like 3x plus x minus 3, you may not think that that's a binomial. But if we simplify this, because 3x and x are like terms, we get 4x minus 3, and this is a binomial. Now our next word is a trinomial, and we know that the beginning word tri means 3. Bi meant 2, this means 3. So 3 terms, okay? 2 terms. So this is a combination of 3 terms, or 3 monomials. So we have a 5, which is a term. It's a constant as well, just a number. A variable and a variable. We can't combine it and make it simpler, so this is 3 terms, so that's a trinomial. Again, term, 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 and we can't combine to make them simpler, and this is 3 terms, a trinomial. Now, a little bit more specifically, we can have quadratics. Now, quadratics can fit into a trinomial or a binomial or a monomial. All of them are polynomials, but this is very specific. These are polynomials whose highest exponent is 2. So we notice here we got x to the 2. That's just one term. That could be considered a polynomial, a monomial, and specifically a quadratic. Again, we have the highest exponent as a 2, and if we look closer, this has 1, 2, 3 terms. So this could be considered a polynomial in general, a quadratic very specifically. We can also say it's a trinomial because there's 3 terms. Here we have an exponent of 2, it's the highest exponent, but we have 1 term, 2 terms. So when we have 2 terms, we can consider this a polynomial in general, a binomial because there's 2 terms, and most specifically a quadratic binomial. All right, so let's see if we can identify some of these. So we have 3y squared. So the first thing you have to say, is it a polynomial? Well, yes, this is a polynomial because that encompasses everything. So this is a polynomial, but most specifically, it's 1 term. So it's a monomial, very specifically. Here, we have 2/5 x, 1/3 y, plus 4. We can't combine and make things simpler. So this is 1, 2, 3 terms. So this is a polynomial in general, but very specifically, it's a trinomial because it's got 3 terms. Now this one I have a little star beside. So we have 3x plus y plus x. So in first instinct, we could say it's a polynomial. And if we look a little closer, we see, oh, there's 3, and we might think trinomial. But we see that this x and this 3x are like terms. So this is actually 4x plus y. So when we look at this, this is 2 terms, so this is a binomial. Let's look at D. So D has x divided by 8, 8 is a denominator, and then y divided by 5. So this is a term, and this is a term. There's no variable in the denominator, so this is a binomial. Now E, when we look at it, we have both of these terms have variables in the denominator. These are called rational expressions, which we'll get into that, but this is not a polynomial. Okay, that's the most important thing because it has variables in the denominators. Now, the next thing you have to know how to do is find the degrees of a monomial. And a degree of a monomial is the sum of all of the variables in the problem's exponents. So let's look at the first one. So let me pick a different color here. So we're going to go with a pink here. Let's get us a little bit bigger. All right, so if we look at our variables, we have a variable here and a variable here, and we're going to look at their exponents. So we have a 3 and we have a 2. So add those together, we have a degree of this monomial, because this is 1 term altogether, is 5. Again, we're looking at each variable. We have a 4, we have a 3, and remember when there's not 1, that's always a 1. So this has a degree of 8. Now a number, there are no variables. There's no x, y, any kind of letter there. So this, just a number, a constant by itself, has a degree of 0. So these are just for monomials. And to understand that helps you lead into finding the degree of a polynomial. So this is if you have a whole bunch of pieces together and you want to find what's the degree of this whole polynomial. So we're looking for the greatest degree of any monomial in the polynomial. So we're looking at individual terms and we're looking for the greatest one. So if we looked at this, we could say this is a polynomial. However, we can't go any more specific because this here has 4 terms. Okay, so let's look at the first term. This has a degree of 2 because we're just looking at the variable. This one has a degree of 3. This one has a degree of 5. And this one has a degree of 0. So if we want to think about the degree of this whole polynomial, it's the largest degree of any single polynomial. So this would be 5. We don't add them together. We look at them individually, and the highest one is 5. And this is important because when we move into standard form, this is what we're going to use to help us. All right, let's look at a second one. We have 4x, that's one term, a negative 4 is another term, and then a positive a, b is another term. So this is a polynomial. We can more specifically call it a trinomial because it's 3 pieces. And now we're going to look at each one. We know there's a 1 there, so this is a degree of 1 for this term. There's just a number, so it's a degree of 0. This one has 1, 1, so this is a degree of 2. So this has a degree of 2 for this whole polynomial, which happens to be, most specifically, a trinomial. All right, let's go into standard form. So standard form is a way that we write polynomials. And you can write them in either descending or ascending. So when we think about descending, something is going down. We start from large to small. So when like a plane is descending, it's up in the air. A terrible plane drawer here. And it's going down to land. Okay, so large to small. Where ascending is it's going up. So we start from small to large. So you need to know that vocabulary if you didn't already. Now, if they don't tell you how to write it, if they don't say write it descending or write it ascending, then you always assume and you write it descending. That is what standard form is. And this is like everything has a certain proper way to do something. So descending means we're always going to put the largest amount of exponent degrees first. So let's look at example A. So just like we did previously, we want to find out what each term is. So this is a degree of 5. This is a degree of 10. And this is a degree of 4. Notice 3 and 1. So we got a degree of 4. So if we're not telling you how to do it, we automatically put it in descending. So I'm going to put the largest first. So this term in the middle, 12, x to the 7th, y to the 3rd, is the largest. And the next one is the 9x to the 5th. And whatever sign's in front goes with it. And then the last term is negative 4x, y to the 3rd. So this would be in standard form. Well, let's look at B. So I want you to do this one in ascending and then C in descending. So pause the video if you need to. Give yourself a chance to check and then see if you got it right. All right, B was ascending, so we're ascending into the air, so we're getting small to big. Think about the plane taking off. It's ascending into the trip of the unknown. So we're going to start with small. So our small is the negative 10, so that would go first. So we've taken care of that one. The second one is 5xy, because that's at a degree of 2. Then negative 4x to the 4th, y. And then your last piece is positive 3x squared, y 4th. This would be an ascending. It's very seldom that you see them written ascending unless they specifically tell you. Most of the time, 98% of the time, it's going to be in descending and just as a standard thing, get in the habit of writing it that way. Now, if we look at C, we have a term here, and this is a degree of 5, and this is also a degree of 5. So it wouldn't really matter which one we put if we're doing descending. A lot of times descending, because it's going from big to small, they like to start with our number that's in front. This is called our leading coefficient. When we write something, a polynomial, whatever the number is in the front is the very first coefficient number is our leading. It's like our line leader. So in this one, it's a 3. If there's a negative in front of that number, then you say it's a negative 3 or negative whatever. It wouldn't really matter how you write this one. You could technically write it this way as well, and it wouldn't be wrong because it's in descending order and they have the same degree. Now, occasionally they'll ask you to write something descending, this one says, in terms of x. So we're only looking at the x values. So this one has a degree of 2, this one has a degree of 3, and this one has a degree of 4. So if we're writing in descending, meaning large to small, we'll write the 6x to the 4th first, negative 12x 3 to the y second, and plus 24x squared y squared, because we did it just with terms of x. So that makes a big difference when it says in terms of x. We're just looking at the x variables. It could say in terms of y, it could say in terms of z, whatever it may be. Then if that's the case, we're just looking at that variable alone and not the whole term itself. Now, remember that a leading coefficient is the number in front of the first term of the polynomial, like we talked about previously in example C. And if something is cubic, that means its degree is 3. So if I have something that is 4x to the 3rd, that is considered cubic. Same as if I had 4x to the 2nd, that's considered squared or quadratic, because we talked about quadratic earlier. So make sure you understand your vocabulary, and then you'll do your practice.